This is a short movie to explain the relationship between gravity and projectiles. Projectiles are objects that are projected into the air, and then their flight path is monitored and is normally seen to follow what is called a parabola. This typical parabolic flight path is due to the force of gravity. If we consider this diagram, we can see that diagram A, or figure A, in the absence of gravity, an object that is projected in the air would just simply continue on travelling in whichever direction the projection actually occurred. However, due to the effects of gravity, the characteristics of the flight path are changed to that of a parabola, the shape shown here. Now, the rationale, or the reason why the projectile travels in this pattern, can be seen in the characteristics of the component velocities. So the diagram on the screen at the moment shows the vertical and the horizontal component velocities for an object that is actually projected into the air. So if the projection occurs at the point indicated by the cursor here, we note that as the object travels through the air, the horizontal velocity component doesn't change. This is because in the absence of any influences due to air resistance, there are no forces to cause a change in the horizontal velocity. In contrast, we note that the vertical velocity changes as the projectile continues its path. Initially, the vertical component is diminished until at the top of the flight path, where the cursor is indicated here, if we had a diagram, there would be no vertical component, but the object would still retain its horizontal velocity. Past the apex of the parabola, we note that now it acquires a vertical component velocity in the downwards direction, while still keeping its horizontal velocity. The vertical component continues to increase as it travels towards the Earth. The horizontal component still remains constant, and so this pattern continues. If the projectile travels beyond the point at which it was released, or an equivalent height at which it was released, then the vertical component will continue to increase whilst the horizontal component will remain constant. This will be the case until the projectile hits the ground. So we can see that this changing pattern in horizontal and component velocities describes the parabolic flight paths that we actually observe to occur. Now, in the diagram here, this shows a variety of different parabolic flight paths for objects that are released with different speeds, as shown in the diagram here, and as released at different angles. Now, consideration of the diagram shows that the optimal angle for an object that lands at the same height at which it was released would actually be 45 degrees. It's important to note that this is optimal in the sense of maximizing the range of the object. So in other words, if the desired effect was to maximize the horizontal displacement or range that an object travels, if the object lands at the same height at which it was released, then the diagram shows that you would end up choosing a 45-degree projection angle. Similarly, it also shows that objects projected at different angles from those of 45 degrees will actually travel the same distance when the angle itself is equidistant away from the 45-degree optimal. So in other words, an angle of 30 degrees and 60 degrees will produce the same range if the object is released with the same speed. The 45-degree optimal angle will vary for those objects or those activities where the aim is not to increase horizontal range, or where the object itself is being projected at a different height from which it will land, in which case the precise angle will need to take into account the height at which it's released, as shown on this diagram here, as well as the angle of release. A general rule to follow is where an object lands at a lower height than it's released, then the optimal angle will be something less than 45 degrees. This is the case for sports such as long jump. And where an object lands at a higher height than which it was released, the optimal angle will be something greater than 45 degrees. It is difficult to consider or think of a precise sports activity for which this latter condition applies in an appropriate context. This concludes this short summary of the effects of gravity on projectiles.